Good day, good day, good day. It's been quite some time. I hope you are all good. I hope you are all well on this beautiful Saturday as you are preparing for your chemistry, physical science paper 2, which you are writing on Monday. So, on the WhatsApp group, we have been receiving questions. Students needs assistance in read of reactions as well as chemical equilibrium, calculating KC and stuff like that. So this video, we're gonna make sure that we satisfy your needs and try to meet you halfway. If it's your first time to tune in, please don't forget to subscribe, like, comment, and share, 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 share. Wake up your roommate right now or anyone you stay with at res, at hostel. Tell them that it's about to go down. This is the last push for your June exams. So let's just wait for like 1 minute as people are coming through. So I'd always advise you guys, please don't forget to apply for the institutions which you want to go to. Don't forget to apply for the universities which you want to go. It's so important for you guys to apply. If you don't apply, you won't have a place to go and study at next year. So please do yourself a favor and make it a point that you apply. All the applications are open. I think they are closed in June or something like that. So please do check on the websites, even if it's NMU, UCT, all the various universities across the country. Please make it a point that you apply. The application is still open now for medical students. I think they close in June, but others they close, they have like an extension. But for health sciences, usually there's no extensions. And please make it a point that you apply, you apply, you apply, you apply, you apply. So that next year we will see each other in the campus season. Like, hi, I've been tuning on Yebo Tutor, and it's great to see you on this beautiful year. So guys, please, please, please apply, 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 apply. Okay, now today we'll do chemistry. I know maybe people will like, Yan is doing chemistry as well. Yes, I'm also doing chemistry. I also do physics. I also do life science, geography. I'll try to see if I can stream life science next week. You're also writing life science. The idea behind everything is to be able to assist each other and be able to pass. Okay, so please, please, please share with friends that Yebo Tutors Live. We are here to assist you. We are here to change the world. Okay. Now, today on chemistry, we'll be doing the rate of reactions as well as chemical equilibrium. So, in order for us to just do an overview, I think it's best if we look at a question paper, then we solve the question paper. So, this was June, which was written last year, like in all the province in Eastern Cape. Sorry, this one is the Eastern Cape one, which was written last year. So after this stream, I will send the question paper in our Yebo Tutor WhatsApp group so that people can have access. If you are not on the WhatsApp group, do yourself a favor. Please just join using the link in the description of this video, and also the number, which is just text it. Don't need to direct you directly to the WhatsApp group of ours. Okay, cool. It's about to go down. Now let's get down to business. So as I've said, so I tried to download what we call the what's this? The exam paper or the marking guide or the whatever that is, which is issued by the Department of Education, which have the specific definitions which they want. So I downloaded this so that you guys can get relevant to it. Let me see. Yeah, so it actually shows you, it's like an exam guideline. Okay, so in chemistry, here is chemistry, which is paper 2. So they start from grade 10, telling you about balancing the chemical equations, the aspects of chemical change. This is grade 10. So these things you must be able to have them in your mind when you are writing your exam on Monday. Now we have intermolecular forces. Of course, you must be able to explain the dipole force, explaining the induced dipole forces, the London forces, and of course the strongest of all, which is the hydrogen bomb. So you must have that background already with you, so that when we are now talking about the different types of the functional groups and all of that, you'll be able to apply them. So we have what you call organic molecules, of course, atoms which have carbon molecules, sorry, which have carbon atoms. Then we have different condensed structural formula. We have the structural formula. We have a molecular formula, which really represent all these organic molecular structures, which have their different functional groups. Bear in mind that we have this terminology of intro. We are introduced to, which include saturated, unsaturated, so those kind of stuff. So it's a must, it's important for you to go through this exam guide, and I'll try to also send it on our WhatsApp group so that everyone can have it. Of course, we have alkanes, we have alkenes, alkynes, haloalkanes, we have alcohols, primary, secondary, tertiary alcohols, we have carboxylic acids, then we have esters, we have aldehydes, we have ketones. Then you must be able to do their structural formulas as they are actually showing you. So it's an exam guideline which shows you how to answer even the definitions. For instance, what is a hydrocarbon? So those are organic compounds that consist of hydrogen and carbon only. So it's important to answer those definitions or those questions they ask you based on the exam guidelines, because the moment you leave the is, the moment you leave the in a statement, they try to make it a point that they give you a half mark. They will say it's partially correct. So make it a point that all your answers are partially correct, not partially incorrect. Then you can see the different structures and the function. So this is so important, guys, when you're writing on Monday. The 50 marks, which is on this organic, it's so easy, guys, because it's just alkanes, alkenes, alkynes, and their structural formula, and also their names, to be able to write their names and all those stuff. So please make it a point that you go through that. Of course, the most important of all in the organic molecule, in organic chemistry, is to understand the fact that we have what we call IUPAC naming, and to know the different steps which are supposed to take, to know the different attributes which are supposed to collect and bring forth on the table. Okay, let's just proceed. Of course, to know the different processes, reactions which takes place. Of course, we have oxidation, we have esterification, substitution, elimination, all those things. So by Monday, when you're writing, please make it a point that you understand them. Then this is also grade 11 work when you're speaking about the exothermic, the endothermic, to understand what is an activation energy. So when they ask you what is an activation energy, they expect you to write that it is the minimum energy needed for a reaction to take place. You can't change that definition. The moment you do that, your answer is partially correct. So please make it a point that you do that. Okay, now here is what we are here for today, which is the rate and extent of reactions, of course. So what is important is to understand what is a reaction rate. The moment you see rate, which means there is time involved, okay? The moment, anyway, the moment you see rate of the rate of, there is time involved. So please make it a point that you always know those few things. So reaction rate, of course, is the change in concentration of reactants or products per unit time. As I was saying, you must be able to calculate the reaction rate, of course, which is equal to change in the concentration divided by change in time. And of course, you must also know the SI unit, mole per decimeter cube. Then the questions may be definitely, they'll be like, okay, state the factors which affect the rate of chemical reactions, to explain in terms of the collision theory, to speak about the kinetic energy of the molecules, atoms, the exciting state, all those things coming together. Boom! Something explosive will definitely come. So it's important to understand those few things and understand, okay, this is what we are dealing with here. Of course, you must be able to understand the mechanism of reaction and the catalyst. The catalysts are so important in this section, because if you don't understand the function of a catalyst, you'll be able to do few mistakes. So please make it a point that you go through that. Now, let's go to what we call the chemical equilibrium, the one where people be like, this is easy. This is easy. Okay. I'm joking. Many people say it's hard. Of course, it's important to understand the chemical equilibrium and understanding the factors which affect chemical equilibrium. Okay. So you must understand what is meant by open and closed loop, reversible reaction. It's an important term because they usually ask those things like, what is a reversible reaction? Like, oh, okay, it's a reaction. A reaction is maybe like reversible when the products can be converted to reactants and reactants back to, so it's like vice versa kind of stuff. So what is chemical equilibrium? It's just a small definition which you must know by head and write it when you're writing on that. No, chemical equilibrium, it is a dynamic equilibrium when the rate of the forward reaction is equal to the rate of the reverse reaction. So that's basically the reversible reaction, because we say that it's irreversible when products can be converted to reactants. So those kind of stuff, guys, please make it a point that you always keep them in mind. Then of course we have our KC, which is the equilibrium constant. You must understand the different factors that influence that, and also the application and the principle. That's where we have what we call the Le principle. State the Le principle. Use the Le principle to explain the equilibrium qualitatives. So those kind of stuff, and you can actually use the Le principle to interpret your graphs of equilibrium, to speak about concentration, to speak about the number of moles, the mass, the volume change, all those stuff. So please, 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 please be aware of those few things. Of course, here we are. As you can see, this is physics paper 2, which was written last year in June. Let me show you that in Eastern Cape. So you can see that this is a national senior certificate, grade 12, June 2022. So we'll be going through that paper. Of course, your multiple choice question 10, those things, guys, please make it a point that you ask them. But now let's look at important questions, which is, I think, question number 5, where we are speaking about the rate of reaction. Okay, guys, if you are with us, don't hesitate to ask your questions on the WhatsApp group. You can also ask on the comment section and type that, no, Vian, what are you talking about, so that we can always flow together and be uniform together. Okay, cool. Now let's go. First question. Now in the question, as you can see here, they are saying that, let's do this, put it here. Oh my word, what just happened? Okay, here we are. Yes, thank you. Uh, let's do this. Yes. Now, the decomposition of hydrogen, let's write it down. So we'll start with question number 5. Question number 5. Question number 5. Okay, let's go. Now, the decomposition of hydrogen peroxide, represented by the balanced equation below, is used to investigate the factors that influence the reaction. Right. Oh, so there are factors involved. Okay, of course, you can see that H2, O2, of course, hydrogen and oxygen there, producing the hydrogen gas plus the oxygen gas. Of course, we can see that delta H is less than 0. Is that exothermic or endothermic? It's just a question. It's just a question. Of course, maybe on Monday, 5.1. Is this an exothermic or endothermic? So you must be able to state that due to that delta H less than 0. Oh, okay, this is this, this is that. Okay, now let's answer what you are being questioned here. Question number 5.1. Define the reaction rate. What is the reaction rate? So this is the important definition that everyone must be able to be aware. Of course, if we've already defined it, we say that it's change in concentration, okay, as we have said already, per unit time. Then we have 5.2. Now, besides temperature, okay, besides temperature, write down 2 factors that affect the rate of this reaction. Of course, the first one, let's say, let's just put it that, of course, the first one is going to be concentration. Then the second one, we can even say a catalyst, okay? The catalyst can also affect the rate of this reaction. Now, 5.3. During an experiment 1, 150 cubic centimeter of H2O2, which is that decomposes at 30 degrees in a flask. This is the graph which is showing the experiment, and you can see on the y-axis they have given us the concentration, and the other side they've given us time. No, sorry. The first question, 5.3.1. Give a reason why the rate of reaction decreases between T 2000 seconds and T 5000. Why? Of course, this is easy because we can say that it is due to the decrease in the concentration, okay, of H2O2. Okay. Of course, we've already stated the rates and the factors which affect this, and we say that it's concentration and catalytic. So applying the same thing, like, okay, and we can see that, oh, okay, this is what we are dealing with, and we can see that as from 2000 to 5000, the concentration is decreasing from 1 going to 0.2. So you can see that it is because, or it is caused by the decrease in the concentration of H2O2. Okay, so we're analyzing the graph here. How long in seconds did the reaction take place to reach completion? Of course, it's 5000 seconds. Okay, so 5.3.2 T is equal to 5000 seconds. Okay, 5.3.3. Now, calculate the average rate of reaction. Of course, now everyone knows the rate of reaction is equal to what? So those kind of stuff, of course, we know that it's change in concentration over change in time. Of course, it's changing from 1 to 0 minus 0 minus 5000. Okay, then what will be our answer? Please use your Casio calculator to find the answer for that. Of course, that's going to be 1 minus 0 divided by 0 minus 5000. Okay, that will be the rate of reaction. Then you put it in scientific notation. Because we'll get 2 times 10 to the power negative 4 more decimeter cubed per second inverse. Okay, that was easy. Now 5.3.4. Calculate the volume of oxygen produced during the interval t equal to 0 to t is equal to 2000 s. Assume that the molar gas value at 30 degrees Celsius is 25 centimeter cube more. Assume that volume of the solution remains constant. Oh, okay. Now that's amazing because they've already told us that the volume remains constant. Let's look first at the change in concentration. Of course, change in C is equal to 1 minus 0, 0.2. Then we can see that that's 0, 0.8. Okay, more per decimeter cube. Then, of course, we can calculate the number of moles of this H2O2, of course. So, number of moles of H2O2, and we know that it's CV. Okay, the concentration is going to be equal to 0, 0.8 times the volume which they have given us here, which is 150. Then we convert that 150, that will be 0, 0.15. Then we use our Casio calculator. Let's go! 0.8 times 0, 0.15, then I am getting 0, 0.12. If your calculator doesn't give you this, which means it's wrong. So we have 0, 0.12 more. Then after that, we can actually calculate or we can actually say that by ratio, we can see that from this equation which we have here, everything is balanced. Okay, there is 1 1 1 1, so the number of moles, they are equal. Okay, so we can say that the number of, by ratio, the number of moles of H2O2 is equal to the number of moles of O2, which is equal to 0, 0.12. Okay, 0, 0.12 more. Then from that, of course, our life is already easy because we have been able to understand that by what do we call this? By the ratio. And they said that calculate the volume of oxygen. Now we know the number of moles of oxygen. So now they say calculate the volume of that. Of course, we can calculate by saying that N is equal to V over Vm. Okay. Then after that, we can say V is equal to N times Vm, and our N is 0.12. Okay, multiply by that 25,000. Why are we using this formula? Because they've already told that the molar gas volume at, so we are using that Vm, which means the volume at molar gas. So that is important, so crucial. Okay, then the volume will be equal to 0.12 times 25,000. Then that is 3,000. That is 3,000 uh, centimeter cubed. Okay. Then we are done, which is approximately the same as 3 decimeter cubed. Okay, so we have converted that and we have put that to be in centimeter cubed and also decimeter cubed. So yeah, that's how easy it is. That's how easy it is to solve these problems. Okay. Any question, please feel free to ask us questions. All right. Now, moving forward to the next question. We are done with this one. We're able to solve this fast, quick, and we're out. Now on 5.4. Now we're on 5.4. Now 5.4 says, how will the following be affected if the volume of hydrogen peroxide, which is H2O2, used in the experiment one is doubled? Oh, so the volume is doubled. Choose from increase, decrease, or remains the same. Okay. 5.4.1. How will the following be affected? So, how will the average rate of reaction be affected by the increase or by the volume of this hydrogen peroxide? Of course, this is easy. So we can answer that. The average rate of reaction will decrease, of course. Listen to the question. How will the following be affected if the volume of hydrogen peroxide used in the experiment is doubled? So we know that if we increase the volume of something, of course, the rate of reaction is going to decrease. So we are just applying those same principles which I've been speaking about initially when we were talking about the different principles which you apply here. Okay, so of course, if we increase the volume or if we double the volume, the rate of reaction will decrease because they are inversely proportional. The other one goes up, the other one definitely has to go down. If the volume was going down, which means the rate of reaction was going to go up. Now let's look at 5.4.2. Now they're saying on 5.4.2, how would this affect the total volume of oxygen produced? Of course, it will remain the same. It won't affect. So, of course, as I highlighted before, that look at the fact that everything is just one here. So we have one here, the ratios. We have one here. We also have one here. So of course the volume won't change. Okay, the volume won't be affected by anything. So please be aware of that the volume will always remain the same if we double the volume. Okay. Now moving forward to 5.5. Wow, that's exciting. Super exciting. Now in experiment 2, hydrogen peroxide decomposes under the same conditions as in experiment 1, but a small amount of manganese dioxide is added. The Maxwell-Boltzmann distribution curve of the reaction in experiment 1 and experiment 2 is shown below. So we can see that E2, E1 there, the number of particles. Then they are saying that E1 and E2 represent the activation energies for the reaction in experiments 1 and 2. Now, define activation energy. Wow, it's 2 marks, 2 marks, 2 marks, 2 marks. So knowing these definite definitions, you're already out. I think it's almost 20 marks in the whole paper. Just think about Kabanganj. Just think about it. It's already 20 marks already for you. So what is the activation energy? So it's 5.5.1. Activation energy is the minimum energy, okay, required for a reaction to take place. Okay. I think you also saw it also in the exam guideline that it's also this definition. So the definitions which are only important are only on the exam guidelines. Okay. Now proceeding to the next question, activation energy. It is the minimum energy required for a reaction to take place. Okay. Now describe what is represented by a shaded area in the graph. Where is the shaded area? What does that shaded area mean? What does that shaded area mean? Of course, guys, that's easy. It shows that it is the energy, or we can say that it is or we can actually say that these are the particles with sufficient kinetic energy, okay, so that they can be able to react. I don't have to write that. You just have to keep that in your mind that, okay, the shaded area always illustrate the particles have now sufficient kinetic energy so that they can react. Now, which one of A1 or E2, which is would yield a higher reaction rate, explained by referring to the collision theory? Ooh, that's big. So we're going to explain this by the collision theory. So which one between E1 or E2 would yield a higher reaction rate? Of course, guys, this is easy because both me and you guys, we know that E2 will yield a higher reaction rate. But let's explain this in writing, okay? So we said it's E2, 5.5.3. We said it's E2, okay? Why is it E2? It's E2 because first thing, we understand that the catalyst lowers the activation energy, okay? That's the point number one which you can raise there. We can also say that since, or we can just say more particles have sufficient, okay, kinetic energy, which is Ke, okay, they have more kinetic energy or sufficient kinetic energy to react, okay. Then another point, that's a 2 marks, there's 4 marks there. So of course, one here, one here, one here. Let's have another one, okay. So as a result, more effective collisions will occur, okay, per unit time. So we started by explaining, or we started by saying that, okay, E2 will yield higher reaction rate, and we say that due to the catalyst which has been added, this catalyst lowers the activation energy. So as a result of lower activation energy, the particles now we have more sufficient kinetic energy so that they can be able to react. Okay, then for that, as a result, more effective collisions per unit time. Dango. Now let's proceed to our last question of the day. I'm so excited. We are moving fast. Okay. Now that was 24 marks. Now we are doing 20 marks, which is chemical equilibrium. What is chemical equilibrium? Oh, they didn't ask this time. So those are the definitions they might ask in your exam on Monday. So now we're on question 6. Okay, let's go. 6.1. The following reaction reaches equilibrium at a temperature of 327 degrees Celsius. Of course, DH is less than 0. Okay, if you're able to do that, then after that, you can remember to say, oh, okay,